Hey, welcome to our community meeting. For today, we have one topic on our agenda. Tim Ebert will give an update about the Kubernetes client usage in Gardener. I will hand over to you and stop sharing.
All right. So can you see my presentation?
We can see it.
Perfect. So welcome to my short update on the Kubernetes client usage in Gardener. I'm going to talk a little bit about one of my recent PRs, which finally got merged this week. And it was about using cached controller runtime clients in Gardener. So what was the motivation? Originally, we always used generated client sets, informers, and listers for talking to the Kubernetes API and also the Gardener API server, which aligned with this client Go library kind of informers and client sets and so on. And these informers and listers, they use a watch-based cache. So they use this watch mechanism of the Kubernetes API server to efficiently detect changes in Kubernetes API objects. And as we proceed, we drift towards using more and more controller runtime clients, which are basically easier to use because they only consist of basically one interface, which you can use for all kinds of API objects. And you don't have to use generated client sets for each and every API group. But by default, they don't use a cache, but there is a possibility to leverage a similar watch-based cache. The problem for us or for the Gardener was that the client set we use in Gardener only consists of a non-cached controller runtime client. So every time you do a get or a list, it talks directly to the API server. So for example, to the Gardener API server or to the seed API server if you're inside a Gardenlet controller, for example. What's the problem with that? Short recap on our architecture. So if we take a look at the Gardenlet, which is running in the seed clusters in the Garden namespace, it talks to the Gardener API server for retrieving the seeds and shoot objects, for example. But it also talks to its API server. So if you use Gardener's possibility to shoot a seed cluster, then this API server will also run in some other seed cluster, which you can probably name root or soil cluster. Yeah, and it talks to the API server, for example, to retrieve the deployments of the shoot control plane or the extension objects like infrastructure, DNS entries, and so on. So what is the problem here? These basically reside in different VPCs or might even rely on different infrastructures. So this traffic that the Gardenlet causes to the API servers basically goes through some kind of NAT gateway. It's different on different infrastructures, but mostly it goes to this kind of NAT gateway and causes therefore external traffic because it's calling to the internet. And this is priced by the cloud providers, so we can potentially burn a lot of money if we cause a lot of network traffic here. So the overall goal was to minimize network traffic, and to contribute to this goal, I wanted to optimize the clients we use in Gardener, especially the Gardenlet, because there this network traffic is basically external network traffic. And we want to make use of the cache wherever possible, basically, so we can avoid unnecessary API calls. So if we retrieve some deployment or whatever, which basically hasn't changed since the last retrieval, this is basically an unnecessary API call, and we could use or leverage a cache in such cases. The problem with implementing this was that our client sets that we construct are very short-lived in Gardener, or have been short-lived before my PR. So that means for every reconciliation of a seed or a shoot, we basically construct new client sets. So there might be even 10 client sets for the same seed on the same gardenlet. Yeah. And this is problematic because we can't leverage caches if we construct such client sets in a non-harmonized way. And therefore, in my PR, I introduced a new concept of client maps. This is the new part. And this basically is some form of a central registry for retrieving and storing client sets to Kubernetes clusters. So it can store an arbitrary amount of client sets, and it can also store client sets for different types of clusters. So for example, a client map can store a garden client, but also a seed client and shoot clients. The main function you will probably use if you develop a controller is the get client method. And you can basically just pass a key, for example, for a seed, and you can retrieve the client set that was already created. Or if there is no client set for this key, it will create a new one and start a cache immediately. And basically this call replaces all these calls, new client from secret and so on. So we can have client sets that actually live for the whole runtime of the Gardenlet. And this client set you retrieve from the client map now does not only have a client method, but also a direct client. So you can use this client function to get the cached runtime client. So this is used by default. And if you have to fall back to a direct API call, you can leverage the direct client. And you can also now retrieve the controller runtime cache. So you can construct arbitrary informers instead of using generated informer sets. So this was basically just a quick overview about what I did to give you a heads up, or to inform developers that are working on Gardener or an extension. But I want to give you a short status and outlook. So what I'm currently working on, what is missing, is to automatically refresh client sets on kubeconfig updates. So for example, if you update the kubeconfig secret for a seed you registered for Gardener, the client set should obviously be refreshed, and this doesn't happen at the moment, so I need some adjustments, which I'm working on. And hopefully this will be released with Gardener 1.7, but it's still released behind the feature gate, so it's disabled by default, the cached runtime clients. But if you enable it, all calls to this client function will retrieve a cached runtime client. And if we have released this version, we can basically observe it on our Gardener landscapes to see if we can really reduce network traffic with this effort. And also we have to watch out for CPU and memory usage. So I would like to encourage all of you to use this feature gate for local development or even testing landscapes, and see if there are still any problems with the feature gate. And if there are, please report them via an issue or via Slack, so I can take a look at it and improve the clients. What I also have to do is adapt and optimize the usage in the extensions library and the extensions themselves, so they can also profit from cached clients for basically talking to the shoots. Yeah, but as said, this is behind the feature gate and is disabled by default. So at the moment, there's actually no need to hurry to adapt the extensions. Yeah, that was basically it. Quick update from my side. Now I'm open for questions.
Hi, Tim.
Hi,
I'm
Adel.
Adel. Yeah, I just have a quick question. You said generated informers versus cached informers. What's the exact difference here? So, what's the advantage of yeah, not the advantage, but what is the difference?
So the difference under the hood is minimal, I would say. So the generated informers just use a specific informer, so for a specific kind of resource. But the controller runtime cache, which basically has a generic informer, can watch any kind of resources instead of only one specific resource. But under the hood, they are both using watches and leveraging the same shared informers.
Okay, and another question. So regarding the cache, so you mentioned already CPU and memory. So I guess this would already memory, especially would be more. But like, is there a risk of watching the wrong object because now we cache or we're utilizing the cache, and how can we configure that so that it's based on usage, it's optimized?
Yeah. I mean, the risk is that you blow up the memory usage, right? So if you cache all kinds of objects you retrieve, you risk having really big pods. That's why I want to observe this memory usage. At the moment, there's actually no possibility in the controller runtime to configure which objects to watch or which not to watch. So yeah.
All right, thank you.
Do I have any other questions?
I have a question. Is there any, when using these caches, does the developer has to do something special to ensure that the caches are properly initialized, and or it's somehow coming with your change?
Actually, the cache has to be started. You're right. This client set has a new function called start. So if you construct the client set on your own, you will basically have to call start before using the cache client. But if you are using the client map to retrieve the client set, like for example here, which I adapted in all of our controllers, the client is immediately started by the client map. So you don't have to do anything for it.
The cache is started.
Yes, exactly.
But it probably takes some time for it to initialize?
Probably not, because when the client set is newly initialized, it basically has an empty cache and doesn't watch anything. So when starting the cache, it basically does nothing. The first watch is basically created by a call to get or list. And if it's the object you are trying to retrieve is not cached yet, it starts a watch for this kind of object.
Okay, thank you.
Tim, first of all, thank you for the excellent presentation. I'm pretty keen to test it. Are there also some configuration option, like how long the resources are held in the cache, or they are dropped, or can you configure that, or is it more abstractly set?
You can configure a resync period for the cache. So the period in which the cache tries to list all objects again in order to basically avoid stale cache objects. But the objects themselves are basically kept until they are deleted. So that's not configurable. But the resync period you can configure. It's at the moment statically configured in Gardener, so it's hard-coded, but if we see some necessity, we can make it configurable.
And that was also the reason why you think that we could blow up the memory or so?
Yes, exactly.
Okay.
So if you are watching all the shoots, which you basically have to do for leveraging the cached client, for example, these objects sum up to a lot of memory, and
Thanks.
I had one question more on the cache client rather than the client map itself. You mentioned that the watch will be created if the kind is not already watched, but if on the cached client that is written by the client map, if a get call or list call is made on a kind, when it starts the watch, if the objects are not yet in the local cache, will it be blocking, or some extra code like the client go wait for caching or something like that will still be required?
This is actually done by the controller runtime client. As you said, there is this wait for cache sync. And if the client cache doesn't contain a watch for the kind of object and it is newly created, it waits an initial, or let's say it initially waits for the client to be, for the cache to be populated the first time before returning the objects.
Okay, so the first call could potentially be blocking.
Yes.
Okay, cool, understood. Thanks.
Any more questions to Tim?
Just maybe one question. Is it so control runtime by default doesn't support it, but is it possible? Is there any ongoing development going on control runtime to support such APIs?
Sorry, what do you mean by support for such APIs?
So as you mentioned, so controller runtime by default doesn't, as in default API doesn't support cache call, right?
What call?
Okay, basically the client said you make a call. We are writing this because the control runtime client, when you make a call, it doesn't use cache, so it every time it makes a call to API server, right?
Yes.
So does control runtime, you are using existing feature of control runtime where it has option, configurable option to cache it, or the cache is completely implemented newly apart from
okay, now I got your question. All right, the controller runtime has support for this cache. This is not implemented on our side, but if you do a client.new, so construct a new runtime client, this is basically a direct client, so it talks directly to the API server. But there are means to configure such a cached client already supported by the controller runtime, which I am using now to construct those cached clients.
Okay. Thank
you. Just one last question, Tim. Is there a way to create more than one cached informer, or one informer per object per cache? Do you know that? Because this is looking more like the shared informer concept, right?
Yeah, it is using the shared informers under the hood. Yeah.
Yeah. So if we can kind of like create more than, or scale the number of shared informers per object, so that with more controllers or more watches, we can get more or less impact of stale objects and so on. Not sure, but maybe you know it.
Yeah, maybe you could, of course, construct multiple clients per cluster, but then you would, of course, also exponentially grow the memory size of, for example, the garden.
Yeah, probably that we can talk about it later, because I'm thinking about stuff. Yeah.
Yeah, sure. I guess we anyways have to observe the behavior of the cache, and then we can still optimize it if we see any problems with it.
Agreed.
Okay, thank you, Tim. Then we are at the end for today's community meeting. Next week, we will get a pretty interesting presentation about the scaling out of Raspberry Pi clusters to the cloud, so stay tuned. And thank you very much for attending.
Bye-bye.
Bye-bye.
Bye.